April 1940. Britain is on the brink, desperate for a new fighter. But when North American Aviation claims they'll build a better plane in just 120 days, even the British think it's impossible. Yet this bold gamble sparks the engineering revolution behind the legendary P-51 Mustang. How did a seemingly reckless promise create an absolute masterpiece? And could the fate of the air war really hinge on one radical design? The true story begins with that anxious phone call. A telegram arrives from London, and suddenly North American Aviation is at the center of Britain's fight for survival. The British Purchasing Commission, desperate to fill the skies with fighters, asks North American to build the tried-and-true Curtiss P-40 under license. For most companies, this would be a lifeline, a guaranteed wartime contract. But inside the Inglewood plant, President James Dutch Kindleberger and Chief Designer Edgar Schmood see something else, an opportunity to leap ahead. Schmood, an engineer with a gift for clean aerodynamics and bold ideas, listens as the British outline their needs. Instead of accepting the safe job, he makes a counteroffer that stuns the room. "Give us 120 days and we will build you something better." The British, battered by the Luftwaffe and running out of time, can hardly believe it. Fighter designs usually take years to move from drawing board to flight, but North American has little to lose. If they fail, they miss out on building someone else's old fighter. If they succeed, they could create a new flagship and maybe change the course of the war. Over tense days in April 1940, negotiations move quickly. By April 10th, the British agree to take the risk. 2 weeks later, the first design drawings are approved. On May 4th, detailed plans are signed off, and by the end of May, a contract for 320 new fighters is in place. The clock is ticking. Schmood and his team now have just 4 months to turn a blank sheet into Britain's new hope. The doors at North American's Inglewood plant never seem to close that summer. Blueprints become aluminum, aluminum becomes wings, and day shifts blur into night shifts. Engineers and machinists work side by side, skipping sleep, driven by the promise that the impossible can be done. On September 9th, 1940, just 102 days after the contract, an unpainted prototype, the NA-73X, rolls out onto the tarmac. It's missing its engine, but the airframe itself is a statement. A fighter born in a fraction of the time it usually takes. The team cuts months off the schedule by using proven components wherever possible. The Allison V-1710 engine, standard U.S. instruments, and .50 caliber machine guns are all off the shelf. But the real leap is in the wing. Schmood and his engineers pore over the latest NACA research, settling on a laminar-flow wing with a thickness-to-chord ratio of just 14.5%, far slimmer than any contemporary fighter. Every rivet is flush, every seam smoothed, every surface polished to near perfection. The goal is simple: reduce drag to a level no other fighter can match. On October 26th, test pilot Vance Breeze takes the NA-73X into the air for the first time. The Mustang handles beautifully. The gamble works. With large internal fuel tanks and a remarkably slippery shape, the prototype hints at range and speed no one expected from a fighter built in just over 3 months. But early Mustangs reveal a flaw. At low altitude, they slice through the air with speed and grace. Above 15,000 feet, the Allison engine hits a wall. Its single-stage supercharger can't keep up with thinning air. Power drops sharply. Where the biggest battles are fought, the Mustang struggles to climb or even hold speed. In May 1942, Rolls-Royce engineer Ronald Harker flies an Allison-powered Mustang. He's impressed until he climbs. Harker later writes that the airframe is a marvel, but it needs a 2-stage, 2-speed supercharged engine to unlock its true potential. That observation sets off a chain reaction. On Packard assembly lines in Detroit, American workers build the V-1650 Merlin under license from Rolls-Royce. Producing nearly 1,500 horsepower, it pushes the Mustang to over 440 miles per hour at 30,000 feet, matching or surpassing anything in the sky. But speed isn't the real breakthrough. North American engineers design a fuel system carrying 269 gallons internally. Add two 108-gallon drop tanks, and the Mustang's range stretches to 1,650 miles. For the first time, a fighter can escort bombers from England to Berlin and back. Range and speed now work together, turning the P-51 from a tactical fighter into a strategic weapon. The cost of not having that weapon becomes brutally clear on October 14, 1943. Nearly 300 B-17 attack Schweinfurt without sufficient escort. 60 bombers are lost. Hundreds of airmen are killed or captured. Without long-range escort, daylight bombing is unsustainable. What made the P-51 Mustang truly dangerous wasn't just that it could fly farther or faster. It was that it changed how pilots thought about the sky. Before the Mustang, escort fighters lived on a clock. Pilots constantly watched fuel gauges, knowing that every mile deeper into enemy territory shortened their odds of survival. Decisions weren't made tactically, they were made by necessity. When fuel ran low, escorts turned back, and bombers were left alone in the most hostile airspace on Earth. The Mustang broke that psychological ceiling. For the first time, Allied pilots could plan missions assuming they would stay. They could loiter. They could wait. They could climb above expected intercept points and choose when to strike. Air combat stopped being reactive and became deliberate. This shift was felt immediately by German pilots. Luftwaffe veterans later described the unsettling realization that the Americans were no longer bound by geography. The old rules, attack after escorts leave, disengage near friendly airfields, no longer applied. Mustangs followed them home. Airfields that once offered safety became ambush zones. Even landing was no longer a relief. The pressure was relentless. German pilots were forced into repeated scrambles, burning fuel and exhausting crews. Aircraft could be repaired, factories could rebuild, but pilots, especially experienced ones, were irreplaceable. Each engagement chipped away at a finite human resource the Reich could not replenish. The Mustang also democratized survival. It was forgiving to fly, stable as a gun platform, and predictable at high speed. Young pilots with limited combat experience stood a real chance against veterans. This mattered in an air war increasingly fought by men barely out of training. The aircraft didn't demand perfection. It rewarded discipline. On the bomber side, the effect was equally profound. Crews began to notice that the escorts were still there on the way out, then on the way home. Missions that once felt like suicide started to feel survivable. By February 1944, the Merlin-powered P-51B arrives. During Operation Argument, Big Week, Mustangs roam deep over Germany, diving on enemy formations and strafing airfields. In 6 days, the Luftwaffe loses roughly 600 aircraft. Bomber crews who once braced for disaster now see Mustangs overhead, and the odds begin to shift. The P-51D brings the final refinements. A bubble canopy eliminates blind spots. 6.50 caliber machine guns deliver sustained fire. The K-14 gyroscopic gunsight handles deflection automatically. Every lesson learned in combat is built into the aircraft. By war's end, more than 15,600 Mustangs are built. P-51s score nearly 5,000 aerial victories, more than any other Allied fighter. Bomber losses on deep raids drop from nearly 10% to around 2%. After the war, the Mustang continues flying around the world, serving into the 1980s. In Korea, it performs ground attack missions jets cannot. Today, more than 150 remain airworthy. Beyond records and statistics, the Mustang's true legacy is measured in lives saved. It stands as a reminder that true engineering mastery isn't about chasing novelty, but about solving the right problem at exactly the right moment. In a world obsessed with speed, the P-51 Mustang proved that endurance and adaptability win wars and shape history. If you liked this video, don't forget to like and subscribe. Thanks for watching.